So should we start the session? What is the decision? 25 people are here. I mean, including. Let's start because recording will be there. So those of you who miss some session, you can see the recording. So we'll start with basics of meta-analysis. In this basics of meta-analysis, we have tried keeping very less of statistical concept and more of applied. Applied means how you have to do it. We are not going to teach you the underlying principle of meta-analysis, or there are many theoretical part of meta-analysis. What we will focus more on how you will extract data from the table of a particular article, how you have to enter the data in the Excel sheet, few concepts of this meta-analysis, which is important to understand and interpret your result, and how to do the various analysis using whether it is a mean standard deviation or proportion or odds ratio like Anuradha was telling 2 by 2 or hazard ratio and so on. So during the systematic review, again there was a question in the chat box like how will we come to know regarding the heterogeneity in the systematic review. So for that also you need to enter the effect size or the outcome in the statistical analysis software like Jamovi or JASP or any other which you are already doing it. We have used Jamovi, that's why. But again, there's a value of I square, and there are measures. We will see that measures of heterogeneity. So that measure of heterogeneity, when you see it objectively, you report it, and then you decide. Like that if the heterogeneity is more, seeing the objective criteria. So this heterogeneity is reported both on the basis of subjectively and objectively. Subjective, when you are doing it, you will find that the outcome is varying, the confounding factors are there. There are like all the three types of studies are there: low bias, moderate bias, and high bias. Even if so, seeing those, you can say like there is a variable amount of heterogeneity. But again, that is a subjective statement. Objectively, you have to enter the data in the outcome measurement in the statistical analysis software. And when you analyze it, you report R square. And on the basis of that, you take a decision of whether you want to continue with the meta-analysis or you want to stop at the level of systematic review. So we will follow some general and specific guideline. So some general concepts from the systematic review is like if there is availability of data, then you can go ahead with the meta-analysis. You have to see regarding your outcome measurement, whether the outcome measurement is consistent across studies or not. Like Anuradha just inquired that there is one measure where they have reported like chi-square, that is 2 by 2 table, or maybe the n and total number, it is in proportion. And in some study, it is the mean and standard deviation. So then what you do, you pool the results of the similar outcome. Means if there is a like mean and standard deviation in those many studies, you will pool only those studies, the result of meta-analysis, where this outcome variable is there. And then regarding the sufficient number of studies. So this question is often asked like how many studies should be there in case of this number of study for the meta-analysis. So meta-analysis is like we say like even at least 2 studies are needed to perform a meta-analysis. So minimum of 2 study. Regarding the homogeneity of study, if you see the value of I square and if the study is homogeneous, that means less than 75%, we will see these objective criteria and then the statistical feasibility. That means whether you can combine all those different measure or everything, you have to convert it into effect size. And like I think Dr. Hari was telling about the JASP, and Dr. Shamshad has just been seen in the JASP interface that you can perform meta-analysis on JASP only on effect size. That means if it is a proportion or like other, it is more of a it's like more of a comprehensive meta-analysis types where it converts all the variable into effect size. But again, I think we have not explored that. Frankly speaking, maybe next time we may plan to have a meta-analysis on JAS, but we have done only on JAMOVI. So coming to this specific context to our example, so you have to review multiple studies to see what is the outcome, and that you have committed in the protocol also, what outcome you are going to see. So like in this case, mean duration of diarrhea, that is our primary outcome. And we have studies that has consistently reported this mean duration of diarrhea along with standard deviation and sample size. So we can conduct a meta-analysis using this mean duration of diarrhea in JAMOVI. The second thing is you can do the studies lasting for more than 4 days or less than 4 days. That means 2 by 2 tables we can have, because author they have reported, and you can club those numbers, and then you can make this chi-square, and not chi-square is not needed. It's only the 2 by 2 table is needed, and that we'll see how we can do taking this odds ratio. And for this outcome, you have to check the studies that has reported the number of children with diarrhea lasting 4 or more days in both group, probiotic and control. And if this data is available, then we can calculate the pool odds ratio.
Excuse me, ma'am.
Yes, Dr. Govardhan.
Regarding the previous slide, ma'am, you have taken two different variabilities for conducting meta-analysis using mean duration and one more diarrhea lasting for 4 days. Is it specific that the odds ratio should be done for like this kind of intervals, or it is just taken as? I'm not getting that.
Actually, this we have, because the reference article which we have used for this workshop, they have used both these two type of measure to show the odds ratio. That's why we have taken for this workshop purpose. Otherwise, it is up to you. That means that it depends on the availability of data also. So odds ratio, if that, because I cannot decide at random like what will I take. I have to decide based on the availability. So I will, when I am doing this systematic review and synthesizing the qualitative study, at that time only, while seeing the table, I have to keep in mind what effect size I can take so that I can have a meta-analysis. So because when we were performing the ADHD, I will just share, towards the end of this workshop, there is a session which we have like tried to share our experience of meta-analysis with that air pollution and ADHD. So there, when we started doing the meta-analysis, initially we committed that we will do it on the mean duration, standardized mean difference, and the odds ratio. But when we started seeing the data, odds ratio, there were many studies which reported hazards ratio, HR, because they were survival. There were few studies which reported standardized mean difference. And like in the overall scoring of this ADHD. And there were few studies which has reported only odds ratio. And there were few studies which has reported only relative risk. So what we did, like since we thought that ADHD, the prevalence is low, it is less than 10%. So in that case, if the prevalence is low, and we have seen the literature, then you can take these OR and AR together. Means you can perform the analysis, pool the result. Otherwise, odds ratio and relative risk are two different distinct concepts. But we say that studies of having very less prevalence, this value of this odds ratio and RR becomes almost same. So that's why we have taken these RR and OR together. HR we did separately. And then we did not have adequate study for this mean difference. So we did not have, we could not do the meta-analysis using mean difference. So whatever you commit in the beginning, because in the beginning you don't, review the studies to that extent. Later on, when you see the studies, then you check for the availability of data. And this decision of meta-analysis regarding one study or two study, it can only happen if you can see some data. And many times you devise your own strategy also, like the way, like you can see here, the author has done like more than 4 days. So I said that a minimum of 2 studies are needed. So even if you get 2 studies, having similar outcome, means if measurement of outcome, then also you can perform a meta-analysis.
Okay.
That decision is entirely dependent on the availability of data which you review. And this because we have planned this workshop only. I mean, we have not done any systematic review in for this probiotic and diarrhea, but to have a hands-on experience, we have used a reference article, and there they have used. I'll show you that article. I think we have shared also for this. So how far is valid if we take two studies for meta-analysis? Valid means, like, of course, if you go through Cochrane, yes, you will see that there are many. It depends all about they. If you see the Cochrane collaborating group, they take care of homogeneity so well that they try to match everything, and then they combine the result. So in the subgroup analysis, you will see that there are many results where they have only done the pool analysis of two study, and again see how it works if some other study gets added, because they what they do, they continuously revise their meta-analysis in the next year if that study, because they are continuously working on that particular topic. It is not like us who have started one topic and left after we have published. So they so continuously study gets added in their pool. So probably if you start with two, there can be a case that next year a few more studies might get added. So it is, you can start your meta-analysis even with two studies. That is accepted. We have seen, and that's, I think that guideline is there in Cochrane as well, that you can do meta-analysis of two, if even if two studies are there. So now, in the specific context to this example of probiotic and diarrhea, if you see the, I mean, we will see this heterogeneity and the measure of heterogeneity. So once we gather this preliminary data, we see the difference in the study design. So like we have seen all the columns, the difference in study design, the population, the intervention, the dose of intervention, the when they are measuring the outcome at 3 days, 4 days or so. And if the heterogeneity is too high, then again, you try doing the subgroup analysis. Subgroup means like there are various strain of probiotics. So you can try taking similar strain, like maybe lactobacillus group strain separately, and then symbiotic group separately. You can do a subgroup analysis. You can perform the whole together and then perform the subgroup. So that facility is there in GEMO. We also, you can select case and you can perform that subgroup analysis, and it is there in the RevMan also. So both, we will see how we can do that. So this is just an example. Here we have changed the data point. So we have entered the data like this. That means in the first column, it will be the total number of the individual of the children in the probiotic group, the mean duration of diarrhea in the probiotic group, and this we have taken in hours. 160 is in hour, it is not in day. And then this is the standard deviation of this group, and this is the mean. Okay, so here we have not given, this is the number. We have not given the standard deviation. Otherwise, in GEMO, it gets followed by standard deviation. So it is only the number and mean. And then again, number in the standard therapy, which may be a placebo or ORS, or mean of standard. And this is the mean difference. So if I have to calculate the mean of all these difference, what is the value of that? So I have to calculate the mean of this mean difference. So please calculate this average of mean difference. So Dr. Geeta is asking, even if we have 24 papers, if only 2 have homogeneity, shall we do meta-analysis for those 2? So you keep doing, initially you do meta-analysis. That means you see for the, in the qualitatively, you see what is the, homogeneity. And then what you do that uh, overall you can perform, and then you can try doing a subgroup analysis also. We will see that, Dr. Geeta. You can do that. The I square, your aim is to reduce the I square. That means the heterogeneity should be less. So if with two studies you can have a less of I square, you can perform that. Okay, so let me have a look at the chat box. So Dr. Anuradha is saying minus 23 or 23. Okay. So now we have to calculate average of all these mean differences. And it is minus 23. So can I say that the pool of this mean difference is 23? Can I say that? Can we simply take the average of this mean, and can I say that the pool mean difference of this whole 5 studies, the mean difference of the duration of diarrhea is 23, 21? What is your answer? Yes or no? So Geeta is saying yes and Subhapriya is saying no. So answer is no. Why no? Because in this case, we are giving equal weightage to all the studies. Whereas you will see in meta-analysis, there is something known as the weight of the study, which depends on the sample size and a lot of other factors also. So that can happen only when we give equal weightage, but we don't give equal weightage of all these studies. And that's how we calculate a pooled estimate. And we give a weightage to all these studies, and there are ways to do it. So now if you see, we'll see that in case of meta-analysis also, when you go for a type of model. Now I'm not going into the very much detail, like I said, of the statistical concept, but we define 2 types of model application in case of a meta-analysis. There is something known as the fixed effect model, and there is something known as the random effect model. So what are these two concepts? So fixed effect model, that assumes that underlying population mean is same. That means if there is a homogeneity from where you are withdrawing the sample. For example, I am doing something from one school. Let's take this example, and I think Borenstein in one of his session also has commented on the fixed effect using an example of school. So if I am collecting many subgroup of students from single school, so what I'll say that yes, since that school will be catering to a particular population generally, so the population, the underlying population is homogeneous. So I can say that whatever mean of that particular sample will come, that will be like all the mean will be very much similar to each other. So this is known as the fixed effect model. So when we say that the studies, so that I talked in case of a person, but when we say that the studies are very much identical in their population or intervention. Suppose if I am doing taking studies only for India or maybe only from Bihar. So I can say that there's a less of, or only from like East region, only UP and Bihar, because if you see many things are very common for UP and Bihar. So if I'm selectively selecting studies from UP and Bihar and taking doing the meta-analysis of similar type of intervention, and outcome measurement is also very similar and the processes are also very similar, then I'll use a fixed effect model. And this model assumes that there is only one true effect size. True effect size means the population true effect size. And that is consistent across all these studies. Here there is there is not many effect size. There is only one effect size of the population. And that's why weight, how do we assign the weight? So weight assignment is done on the population of sample size. So the studies having larger sample will get more weightage, and studies having less sample will get less weightage. So that is the fixed effect model. Coming to if you see this diagram, so for example, in this case, what this we have taken from the book, which is the meta-analysis by Borenstein, and we have shared that book. Those of you that's a little statistical book is, more of statistical formulas are there in that book. So that's why maybe it is difficult for people who are not very well versed into understanding those formula or not. Otherwise, even if if you just understand few concepts. So one very important concept, what he always emphasized, that Ideally, if you see, read meta-analysis, generally people do other way around. Means they see the value of I square. And if it is a too much heterogeneous, then they go for random effect model. Otherwise, they go for fixed effect model. Whereas the correct strategy is you should see the studies. Studies means and the heterogeneity. So generally in health, generally most of the time it will be the random effect model. It will not be the true effect model which will be applicable. So understanding the fixed effect model, if you see this is study 1. So this is the true effect size of study 1. This is true effect size of study 2. And this is the true effect size of study 3. And this is the pooled effect size. So you can see that the true effect size is same for all the 3 studies. This we understand by the fixed effect model. And if you see, this is the population. This value is the for the population. And this, if you see study 1, this is the value of effect size of study 1. This is the effect size of study 2. And this is the effect size of study 3. So if you see this eta 1, eta 2, and eta 3, that represents the distance from the true effect size, and this is known as the sampling error. Sampling error means there must be some inadequate sample. Because of that, whatever outcome has come, that is this lying this much distance. If the true is like 0.6, so here the effect size it is up till 0.4. So there is a difference. So this eta 1 is known as the sampling error. This eta 2 is known as the sampling error again, and this is again a sampling error. So whatever
हेलो
distance,
मैम
yes, Dr. Anuradha.
मैम ये लास्ट वाला पैराग्राफ लास्ट जो है ना ग्राफ आप प्लीज एक बार एक्सप्लेन करें
This one, the lower 1.1.
हाँ जी जी मैम
So this I'm explaining that there is a only single true effect size. So all these are having a single true effect size if the population is homogeneous. If the population is homogeneous, the outcome I have measured it is homogeneous, and there are very less variation. That I assumption is like there is only one effect size. There's only one underlying effect size. So all the studies which are being reported, the difference which you can see, this is only due to the sampling error. There's no other error. Okay. So like in case of a diarrhea, if you see, like if the studies are very homogeneous, then there will be underlying only a mean duration of diarrhea which will be fixed for all the 3 studies. And that's the assumption, like let's see that may be 3 days or 4 days or whatever. And then what the studies they have reported, probably some study reports 5 days, some study reports 2 days, some study report 6 days. So there's a difference from underlying assumption. Underlying is like all the study will have 3. And then there is a difference of 1 or 2 or 3 days from this fixed. But that difference is only due to the sampling variation. Why sampling variation? Because sample size is different. See, the studies which you have just reviewed, there were like 46 samples also, and there were multi-site studies also where the number of sample size was very huge. So the error which you can see, it is due to the sampling error in case of a fixed effect size. I mean fixed effect model. So this is the assumption of the fixed effect model, that there is only single true effect, which is 0.6 in this case, and the observed effect, which you are seeing, like 0.7 in this case, or 0.5 in this case, or 0.3 in this case. That is due to the sampling error, and that sampling error is these 3. Have you understood, Dr.
जी मैम यस मैम
Anuradha? Sorry.
हाँ जी मैम
Okay. Now coming to the random effect model. So random, and in fixed effect model, you should remember the same example. Like if from a homogeneous population you withdraw sample, so you assume that the underlying this thing will be same 1, and from there you are withdrawing sample. Similarly, you are having studies. So the studies having similar nature, it will have underlying 1 effect size, and the difference which you are observing, that is due to the sampling variation. There is no other variation. Other variation means like confounders, type of intervention, duration of follow-up, regarding biases. All those are not there. It is only due to the sample size. That's the assumption. Okay. Now coming to the random effect model. Random effect model is used when there is a sufficient evidence. When you review your systematic when you do the review your systematically your studies which you have included in the final synthesis, then you see that you just have seen there is so much of geographical difference. Studies from Australia, study from India, from Turkey, population are quite heterogeneous. The characteristics is heterogeneous. The dose of intervention is heterogeneous. Follow-up time is heterogeneous. Sample size is heterogeneous. I mean, there are people who are 50. So there is not single source of heterogeneity. It is not only sample size which is heterogeneous. Lot of other factors which is heterogeneous. Right. So this assumes that the studies are quite different in terms of many variable. That's why you cannot assume a single true effect size for all the studies. And you assume that there is no single true effect size and there is a variability within the studies and between the studies. So whenever you assign weight, it is not only on the basis of sample size, rather there are many other factors also which are interplaying into giving weight to a particular study. So this was the example which has been given by the Borenstein, that here you can see in the upper one the same. You can appreciate the difference from the fixed effect. So in fixed effect you have seen just a second, that all these three were lying in the single line. That means study 1, study 2 and study 3. For all these three studies, the true effect size is same. And the observed effect size was this, which was due to the sampling error. But in case of random effect model, you see that there are three true effect size. The true effect size for study 3, if I talk about study 1. So the study 1, the true effect size is this one, in between 0.5, let's say 0.55. And for study 2, the true effect size is this thing. And for study, not this one. For study 2, the true effect size is this one. And for study 3, the true effect size is this, which is 0.5. And then there is an overall effect size. This is the pooled one, okay, which is 0.6. So now there are two type of variability. So if you take only example of study 3, so I am only taking this study 3, this one here. So you can see 0.6 is your overall effect size and this is your true effect size for study 3 and this is the observed effect size. So there is a two source of variability. There is a sampling error and there is another variability which is known as tau. Okay, so again this is something like ANOVA. In ANOVA, there is a within subject variability and there is a between subject variability. So simple, if you can recall the same concept, here there is a error between the observed effect size and true effect size of that study, and then there is a overall effect size. So there is a difference of overall, which is this tau. So there are two sources of error. It is not only the sampling error, rather sampling error plus another error which is known as tau. And that's why you will see that the relative weightage of each study is not only dependent on this sampling error, rather on this tau also. We are not going to tell you the statistical concept behind this tau, how it is calculated, how it is taken into account, because that is beyond the scope of this workshop. For this workshop, you only understand that in case of a random effect model, there are two sources of error, sampling error and the tau. And that's why the weightage which has been assigned, it is not only on the basis of sample size, but the tau also. And in health, that's the blanket statement. In health, 99% of the time, your choice of model should be random effect model. That means generally that you will find that the studies are heterogeneous. What people do, if you apply fixed effect model, you will have a very narrow confidence interval. So many times you will see that just to have a narrow confidence interval, people go for this fixed effect model. But the decision whether you should go for a fixed effect model or a random effect model, that should not be the post hoc. Post hoc means you should not be performing the heterogeneity statistics, and then you will see the result. We'll show you. People write like the value of I square was more than 75%. That's why there was a lot of heterogeneity. That's why they have taken the decision to go for random effect model. So the decision of random effect model should not be based on I square, rather than it should be based on the heterogeneity of the studies, the subjective heterogeneity, which you decide. And in health, like you know that there are geographical variations and there are variations in many other components. That's why in most of the time, it will be this random effect model which will be applicable. Am I making sense? So you can remember, those of you who don't want to understand more of the statistical jargon, you can just remember that go for this random effect model rather than the fixed effect model in your case if you are performing a meta-analysis. Am I making some sense to you? I don't know. Because now it has shifted more of towards, can I see the chat box? Okay, Dr. Geeta and Dr. Hari has said yes. So this is again, he has shown this with a this thing, bell-shaped graph, the same. The study 3 he has shown, and this he has shown like between study variance and within study variance. So now we will understand. Now I will be explaining the output which we get in the meta-analysis, the various output and the interpretation of this output. This is only I am explaining theoretically. When we will do it in GEMOV, I'll explain this. So starting from this is again one meta-analysis of cardiovascular disease. And in this study, I have taken this study just to show you what are the various components of a forest plot. So this is a forest plot, and this we have taken from that study, the same study, this one, Christopher P. Cannon, meta-analysis of cardiovascular outcome trials, comparing intensive versus moderate statin therapy. So in a meta-analysis, these are the components. So what are these components? So there's a study name. So you first column is generally of a first author name, and you label your study like that. The second is regarding your outcome measure. So in this case, the outcome measure is your risk ratio. So risk ratio is the effect size of each study, and then this relative weight is assigned. And this relative weight we have just talked that this weightage in case of a fixed effect model, this is dependent on the sample size. So and this diamond, this square, the size of the square, it tells you regarding the weightage of the study. So you can see here, which is the largest square which you are observing here in all these 4 studies. Prove it, A to Z, TNT and ideal. Which is the largest square? Yes. So Dr. Vishnu Priya, Farzana, Geeta, ideal. Very right. That is the largest this thing. So you can say that the sample size, maybe even the weightage, you see that it is very much similar, 31% and 37, TNT and ideal. So these two are having the largest effect, this thing, sample size. Sample size, I have not written sample size here, but if you go back and see, then sample size is only, it will be larger here. And coming to the next, it is the pooled effect size. The summary which you can see here as a diamond, this one, this is a pooled effect size. And this limit, this is the confidence interval. This is the value of pooled effect size. And these two limits, they are the confidence interval the two like tip of this diamond is the confidence interval of this pooled effect size, and then this is your confidence, this is your precision of effect size, means like how wide, this is the confidence interval of each two studies, I mean each of these studies, and the size of square denotes the weight assigned to this study, and this is the p-value. So again, can you say the study with the more precision gets more weightage in meta-analysis? If you see this, you have commented on the size of the square. And if you see the size of the square, it is like directly proportional to the inversely proportional to the confidence interval. Larger the confidence.
Hello, ma'am.
Yes, Kanath.
How weight are assigned?
Weight are assigned means you want to ask like statistically or conceptually.
Statistically.
That was soft. That you don't have to do. That will show.
Okay.
The software decides for the weight because you
Software.
this is all theoretical. We will all see this. This output you will get in Jamovie.
Okay, okay.
I have not told you anything right now. To be everything which you see here, you don't have to do. You have to enter the data in the Jamovie, and then Jamovie will calculate all these statistics for you. But you should know, that's why we are telling you beforehand. I'm just introducing these concepts. I'll again tell you once the output is there in the Jamovie.
Okay. Thank you, ma'am.
My pleasure. So I was talking about the width of the confidence interval and the size of the diamond. So what can you see here? Is it directly proportional? Width of the diamond means the size of the diamond. Can you see that the larger, the larger the confidence interval, the smaller is the size of the diamond in this case. Can you appreciate that? Yes, can I see the chat box?
No, ma'am, but you can see in Prove It trial and TNT.
Yeah.
Even though the size of the square is like different, it is like the confidence interval seems to be more, right?
No, you have to compare from the first two, na? Prove it and A to Z. So where the confidence interval is more, TNT ideal or prove it and A to Z?
In Prove It only, no confidence interval is more.
It is less. If you see the value, it is from 0.8 to 1, right? If you see this, again, this is this,
Okay.
these two confidence interval are lesser than these two, isn't it? They are having a very wide. You can appreciate from the, breadth only. So you can say the study which are more precise. More precise means narrow confidence interval. And precision is also dependent on sample size. The more sample size, the study is more precise. So again, they are related to each other. So the study with more precision gets more weightage in meta-analysis. Like I've just given you the example with this ideal and prove it. So now there's a confidence interval of the pooled effect. So confidence interval, this one, I have just explained you the tip of this diamond. This is the confidence interval of this pooled effect, these two. And like the value is if you see the value, it is 0.85. And if you see the confidence interval, it is 0.8 and probably it will be, I don't know, 0.95 or something. Value is not given. In the statistical result, it is there. So what is this confidence interval of pooled effect? So confidence interval, basically, you know the concept of confidence interval, that it gives you a measure of the generalizability, like where the population mean will fall. So if some other person does this study, then the study, the effect lies in between those two boundaries. So in this case, you can see it generally the confidence interval, it tells you the precision of the pooled effect size. And in this study, which we'll do, the confidence interval was -32 to -13, and the mean effect size was 22 hours. So 22 hours means like and the confidence interval means that we are 95% confident that the true effect size will fall in between 32 hours to 13 hours if we are giving the probiotic. So it again shows your predictability. I mean, not predictability. It shows how much confident you are when you will conduct the study. You yourself will conduct the study, or someone else will conduct the study. So this we mean by the confidence interval. Otherwise, you also know what do we mean by confidence interval? 95% confidence interval. Now, second one is the prediction interval. So there is something known as the prediction interval. What is this prediction interval? So it tells you about the future studies. This is a new concept. Prediction interval we have not uh, read till yet. We have been reading confidence interval, but this prediction interval is there in case of a meta-analysis, and it tells you like what will happen if you repeat the study in future. So the true effect size of the future study will vary between these 2 points. So if I say that pooled effect size is in case of this studies minus 22 hours, then the prediction interval we see again. Don't worry, I will show all this in Jamovi. But again, when we'll go to Jamovi, you should be able to understand that there's exists something like this prediction interval. So this prediction interval, it tells you regarding the like the spread of effect size in future. So it tells you like how the future, if it is like minus, if the prediction interval is from 0.5 minus 56 to 10, that means in future if the study will be conducted, then the your effect size may vary between 10 to 56 hours. Means plus 10 means it may increase also. That means if you give probiotic, the duration of diarrhea might increase also. That's why it is showing with a plus sign. So that is the prediction interval. That means it tells you the range of the effect size in the future study. Coming to the, and this is the formula of pooled prediction interval. And here what we have learned about the tau, this tau is also there, which we were seeing that between subject variability. So that between subject variability, or what we call as a heterogeneity. So that is also there, and this is the standard error. These are the formula like standard error of the pool estimate, and this mu is the pool mean effect size. But again, you don't have to remember this. Okay, so what Bhavna has said, to repeat what? Okay, repeat relation between CI and diamond. Diamond, we'll show you there again once again. But that point of the diamond is the confidence interval. So now coming to the, someone has asked like how we assess the heterogeneity. So there are 3 to 4 statistical concepts to measure the heterogeneity. There is something known as the subjective heterogeneity, which we have discussed. Like if there is a heterogeneity in the background population, in the assessment, in the intervention, dose of intervention, measure of assessment, and the unit or metric of using those outcome. So that will be a subjective heterogeneity. When you enter those data into the statistical software, it gives you the objective way of measuring heterogeneity. And first is the tau, which we call it as a between subject variation or between subject variability. So what is this tau basically? So this is the standard deviation of a true effect size. So you know about the true effect size. So if you, you just have to remember this tau is something which represents the standard deviation or the variability of true effect size. And a larger value of tau, it suggests that there are more variability in the effect size. Now there's another thing which is known as the tau square. So like we know that if you square the standard deviation, it becomes variance. So tau square is the variance of the true effect size, and a high value of tau means there is significant heterogeneity. We will also see this. What is the high effect of this tau? Then third is your I square. This you all know regarding this I-square, which is also known as the Higgins I-square, and it measures the percentage of variability between the studies, again heterogeneity. So this is one way, like you can determine the percentage if it is like up till 25% low heterogeneity. If it is 25 to 50%, up till 50, we call it as a moderate. Up till 75 or more, we call it as a high heterogeneity. So generally, more, if the heterogeneity is more than 75%, then you should not perform meta-analysis, because then studies are very heterogeneous. But still, you will see people using this. So what generally done, that people, generally researcher, they first calculate this I-square and then they choose a model. So they say that heterogeneity is less, that's why they have gone for fixed effect, and heterogeneity is more, that's why they have gone for random effect. But it's the other way around. You see the result, during the qualitative synthesis, and if the studies are heterogeneous, you will go for the random effect. Generally in health, they say it is a random effect. And then there's something known as the H square. So what is H square? H square is also known as the heterogeneity index. So it is another measure of heterogeneity. And in this case, if the value of H square, it is more than 1, then that means it is a heterogeneous study. There is a heterogeneity. Larger it deviates from 1, that means there is a higher heterogeneity. So this is again one measure of heterogeneity. Then another is the Cochrane Q test or the Q statistics. So Q statistics, you see the p-value. If the p-value is significant, less than 0.01, that means there is a significant heterogeneity. So, and it follows a chi-square distribution. So we have seen how many measure of this heterogeneity. We have seen tau square. Then we have seen I-square or Higgins I-square. Then we have seen the H square. And then we have seen the Q or the Cochrane Q test. Now coming to publication bias. So this was regarding the heterogeneity. Next is your measurement of publication bias. So one way of removal of publication bias, we have learned this. How can we remove the publication bias? We have done one session yesterday. Gray literature. So gray literature is, if you include gray literature, you can like deal with this publication bias. And again, Dr. Hari Kumar is asking which heterogeneity is better. Generally, you see people report mostly this Q statistics and I-square. That's the most common way of presentation. But again, since you give these value of, you can give value of I-square and H square and Q statistics also. And this funnel plot, yes, Dr. Farzana, funnel plot is there for publication bias. There are other ways also to test for the publication bias. Like there is in Jamovi, this we are telling in Jamovi. There are various other maybe ways to check for these plotting thing. Publication bias in different software. In Jamovi, it gives the output as a fail-safe test. So what is fail-safe test? Fail-safe test, it basically tells you the number. It gives you the number of study, that much, this many studies are needed with a negative result, or the, to bring that effect size to 0. For example, if the value of fail-safe is 855, that means 855 additional studies with no effect would be required to nullify the effect size. That we mean by fail-safe test. And the method which we use to measure this fail-safe test is the Rosenthal method or the Rosenthal approach. And you have to see the p-value ultimately. If the p-value is less than 0.001, that means there is no publication bias. So a significant p-value tells you that there is a no publication bias. This is first test. Second, again, Jamovi gives the Begg and Majumdar rank correlation test. So again, if the p-value is non-significant, it tells you that there is a no bias. So in this case, we don't want this p-value to be significant. In first case, it will be there. In fail-safe, if you see, if p-value, again, it is significant, it suggests that there is no publication bias. In this case, if it is non-significant, then it shows you that there is a no bias. Then there is a third one, which is the Eggers regression test. Here also, it tells you the symmetry around the funnel plot. So if there is a asymmetry, it tells you the presence of publication bias. And a non-significant p-value means that there is no publication bias. Then there's another trim and fill method. And this again, if it doesn't add any studies, then again, the result seems to be unbiased. And then there is a funnel plot. So basically in funnel plot, you see the symmetry. So funnel plot is basically a plotting, which is more of objective and subjective in nature. And these tests tell you the objectivity, means the fail-safe N or Beggs-Majumdar test or trim and fill method and the Eggers regression test. So these are the 4 publication bias tests, which are the objective way of assessing the publication bias. But publication bias you will run only if the number of studies are more than 10, more than equal to 10. If the number of studies in the final pool one it is less than or equal to 10, then you will not perform this publication bias because it is not recommended. So that's the just basic introduction of few concepts in the meta-analysis. Now I will show you how to enter the data. These things will get cemented once you see the Jamovi interface, because right now it is only theoretical. So you may feel a little bit confused. I don't know. You may feel that it is going a little heavy. All these names of the tests and heterogeneity statistics and publication bias statistics. But again, we will repeat these things 3 or 4 times so that it will be there in your mind. Don't worry. So now I'm going to tell you how to, so this was just the basic. Now, the very important thing is like how you will enter the data in the Excel sheet, which Anuradha was asking. So I will just show you. So we have shared the article with you people. And if you see, we have taken the snip from that public from all those articles, and I will show you how we have entered the data. So right now I'm demonstrating if my outcome is the mean duration of diarrhea. This is my first outcome. So how I have entered the data. This is my Excel sheet. So we have shared this Excel sheet and I have made the column like that. First, I will enter the number of study subjects in the intervention group, then mean in the intervention group, and the standard deviation in the intervention group. Because in Jamovi, it is in this sequence. So that's why we have entered the data like this. Then there is a number in the control group, and then there's a number in the mean this thing, and then there's a mean of the control group, and then there's a SD of control group. In this case, let's start with the first study, which is the BASU. Okay, so I'll first show you. So this is the study of BASU and we have taken table 2. So in table 2, if you see the last these three row, they have mentioned the average duration of diarrhea in day. 6.8 days plus minus 2.1, which is the standard deviation in case. And the number of cases to 323, and the control is again 323. These two numbers. 323, 323. This value of 6.8 plus 2.1, 6.8 plus 2 plus minus 2.3. There are other outcome also, average duration of vomiting and average duration of hospital stay, but I am only taking the first one now, average duration of diarrhea in days. So I will minimize this. So let me. I'm enlarging this. Why? Because it will help me in having a two view. So this is one view. And again, this is another view. So coming to Basu, number in intervention. I have taken this number from. So in first row, I will write Basu and year. And then I will write number in intervention. So number in intervention group is cases. It is 323. So I have entered this 323 here. Then mean of this diarrhea duration in hours. Because it is in day, but many people have measured it in hours, someone has measured it in day. So I have converted on this assumption, I will write that I have converted all these days into hours. So these 6.8 days I have converted into hour, and this 2.1 I have converted this into hour. So if you see, this is 50.4. 2.1 into, okay, this is 50.4 and this is 163.2. Coming to the another one, which is the control. So this is mean in number in control. This I have taken from this 323. Mean in control 154.8. So this 6.6 plus 2.3. This I have taken. These value. I have converted this into hours and I have entered here. Mean in control and SD of control. Have you understood how I have entered the data? Remember, one row is for one study. One is for one study and one outcome. If I am entering another outcome like average duration of vomiting, then I again need to have a separate row. So the way we enter the data, how we enter the data when we are doing an individual study, we enter each subject, that means each study participants in single row. That's how here single study will be there in single row. But if you have to use the same study for some other outcome, you will enter that study twice, right? I will show you with another example which we have taken like ergodan or some other outcome also. I'm only taking the mean. Yes, the same. Here it's there. When I'll come to this example, I took and then I'll explain. Now coming to Chen. So this, have you understood this first? Then I'll go to the next. How I have taken the data. Yes, can I see the chat? Okay, thank you. Now coming to Chen, the second one. So first let me. So this is the study by Chen. And if you see, although I think we have colored everything, that's why it is difficult to appreciate. But focus on this. Total duration of diarrhea in hours. 121.4 and this IG and CG. That is like intervention. This IG is intervention group and this CG is control group. And this is the number in the intervention group. This is the number in the control group. This is the mean in the intervention group. This is the standard deviation in the intervention group. This is the mean in the control group. And this is the intervention in the control group. So what I'll do, I just want to show you the exact number. That's why probably I'm. So in Chen, what I have entered 96. So I have taken this number from here. Mean 96. Mean intervention. Intervention 121.4. So it is 121.4. Standard deviation is 13.7. Standard deviation is here is 13.7. This one and can you see? Okay, so Farzana is asking, can't we add extra column for additional outcome? For another outcome, it's better that outcome means like what? Like vomiting or
Yes,
any other.
ma'am. Yes, ma'am. Just
Then
if
in
we
that
are
case, you can have, but once you can enter it, but again you have to make a separate sheet because if some other person has done on vomiting, then you need to take that vomiting into single Excel sheet because sheet will be imported in Jamovie. Otherwise, you can select case also. You can enter it here and you can select the cases. So another row, yes, if it is another outcome from suppose I'm taking vomiting also of that Basu. So I'll another add Basu 2007 and then I'll take vomiting as outcome. You can do that in this Excel sheet also. You can hide that, not hide means you can filter that column, that row in Jamovie. You can do that.
okay, so just to clarify more, we have to filter outcome name to import the Excel or to do
In that case, outcome will be again the mean and SD only.
Okay.
Because the variable,
you have to enter one more column. उसमें decide हुआ diarrhea vomiting.
Yes, that can also be there. See, one thing is like how you have measured the outcome. So, like measure this vomit. If you see the diarrhea, let's see this outcome. Then probably I'll be able to.
Better है कि सब अलग-अलग होता है.
This one, okay. So, like if you want to have this vomiting also, then here it is same. But again, you need to mention whether it is diarrhea or vomiting. So, in that case, you need to have one more column where you will write whether it is diarrhea or whether it is vomiting. Like you can have diarrhea, yes and no, or vomiting, yes and no. Because there are two variables. Then when you will import, you will not know whether it is mean duration of diarrhea or mean duration of vomiting. So, I think it's better to segregate the sheets. Because filtering, again, if there are many studies, it might create confusion. So similar outcome, you can have one Excel sheet. For vomiting, you can again open a new Excel sheet from here and you can enter the data. Like you can just add, okay, and have another Excel sheet. Is it okay? Can we use the different sheets for different outcome?
Totally yours.
Yes, you can use different sheets. You can use one sheet for one outcome. And you can import that sheet into Jamovie and you can analyze it. You can do that.
I think different sheet will be a more useful and more give a clarity or easy to use, or how about?
If you don't want to apply a lot of filters in Jamovie, and because again you have to perform multiple times. You have to put one filter on, another filter off. So it might create problem. So it's better that you have independent sheets. It will be more organized, I should say. There are less chances of error.
To my understanding, what you say is like for every outcome, we have selected only two outcomes, right? The diarrhea, average duration of diarrhea, the hospital stay. So for when we take each sheet for each outcome, the result interpretation will be easy for us.
Import.
Import.
When you import that, so then that analysis will be only for that outcome.
Yes.
So this is this we learned for Basu, and this we have seen for Chen. Similarly, if you see Delgic, let me show you that erdogan, where there are two, in case because there were two control. So if you see Delgic, 60 and 100, you can see the number, and this is okay. Let me show you this then this Erdogan 7 number, because I have entered it twice, because there were two types of probiotics, and that number you can see many times it's written in footnotes. So they are writing like 60 patients, 60. So this number many times you will not find this in table. So that's why I said you have to go through the article very nicely. So yes, like this is the Erdogan. So I'm just focusing on this because we have entered two. So they have compared the efficacy of two different probiotic. So there is one group where this is for the control. See, group 3 is treated with oral rehydration therapy. So this group 3 is control. And group 1 and 2 are two different intervention. So if you see in one row, I have entered the Erdogan 2020 with star. That means I am using this first one, which is the Saccharomyces boulardii. You can write Saccharomyces boulardii also in comment section, in remark section. So 25, I have taken this 25, and then I have written 158.4, this number, 6.6 and 1.7. And then when I have entered this again, then I have taken this second one, which is the 4.1 and the 1.3, this one. This one. And then if you see, I have entered again this Erdogan, but the control is same. If you see the value of control is same in both the case. Here, I have got the same control because I have used this control, 5.9 plus minus 2. So I have entered these twice. Even if you are using the two different strain of probiotic, you have to enter it twice in a column, in a row. So that's what I did in this first 7 number. I have entered this as this number 25 and 158.4, taking this control, and the second time I have kept the control same, but this was another intervention, which was one was Saccharomyces boulardii, this one, and the other was this Bacillus lactis. Right. Have you understood why we have used two different? And since here only the strain is different, but the outcome is same. That's why for different strain, I'm not going to use a different sheet, because it's only the mean and standard deviation of the average duration of diarrhea. But there are two intervention. So I cannot enter the two intervention in single row. I need one more row. That's why I have entered this into two rows, but taking the same control, because control is same for both these intervention.
Excuse me,
Yes, Dr. Govardhan.
ma'am. Regarding this Belgic study is there, ma'am. In that, the number of interventions you have taken 60, but
Yes.
as they're given in the paper, total there are 7 groups, of which 8th one is the control group. So since the control is same for all the groups, can we just tabulate that the results are almost same to all the groups, or we have to mention it separately, ma'am?
So control, I have taken one only. Let me, you are telling about this, na? Dalgic. So Dalgic is group 1, 60 patients. Saccharomyces boulardii. Group 2 is zinc. Group 3 is lactose-free formula. Group 4, I have only taken this Saccharomyces boulardii, because rest is like plus. Saccharomyces, if you see Saccharomyces boulardii plus zinc, Saccharomyces boulardii plus lactose free, then zinc plus lactose free, and then boulardii plus zinc plus lactose free. So they are all combos. There's only one group, the second, this group 1 patients, this group. This is the only, like if you see the duration of this diarrhea, this is the only first one. Because this is this is only with probiotic. The rest is with all other combo. But I'm only interested in probiotic. I cannot take other interventions. Remember, you have to standardize it. If I'll take probiotic plus zinc plus lactose free, then what about the other studies? They have not taken zinc and lactose free formula. They have only taken probiotic. So interventions I have to keep same. That's why I'll only take the first one, this one, group 1. And then there was a control. So control is again 5.35. So I will take only these two. Intervention for this. Yes, so if like Erdogan, if there were 7 different types of probiotics, then I would have entered this Dalgic 7 times, keeping the control same every time and the mean duration of diarrhea different in different intervention. I don't know, am I making sense to you, Dr. Govardhan?
Yes, ma'am, got it. You are just concentrating on the probiotics which has been used rather than the supplements along with it.
Yes, because intervention is different. Again, remember, we cannot compare orange with apple. You have to compare, like, of course, different strain of probiotic you have. In that case also, you can compare similar probiotics also. Like only Saccharomyces boulardii. You can do subgroup analysis. You can only select Saccharomyces boulardii, and that's what we do. Once you do a broad one and then you do a subgroup, only Saccharomyces boulardii if you get, you can only analyze Saccharomyces boulardii. You can only analyze lactobacillus. But again, that only depends on the data which you get. If you get, so you can move from more heterogeneous to homogeneous. Initially, when you will write, there will be a lot of heterogeneity. Then you try seeing the similar study and you can have a subgroup analysis, have an overall analysis, and then have a subgroup analysis where you like outcome you see like in terms of intervention or in terms of like how they, in what metric they have measured it.
Okay,
So,
ma'am.
Dr. Farzana is asking in case of same intervention with different controls. Then again, you need to have again, not twice, you can enter it in 2 rows again. Because the control is different. So the effect size will be different. But, okay. So this is how. So this is the Excel sheet. I think we have shared this Excel sheet. And now I'll show how to do that in Jamovie.
Right now.
So I'll open this Jamovie. Oh, it takes time. So this is the interface of Jamovie. And I think I'll just explain a little bit of Jamovie. You can see there are 2, like on the same interface, you have a data interface. This one is here will be the data. And here will be your output. Then if you see the tab, you have got the analysis. These are the variables. This is the variable. This is the descriptive exploration. This is ANOVA, the regression. And for this meta-analysis, this is the major module. Meta-analysis, these are the options for correlation coefficient, for dichotomous model, for effect size, for mean differences, which we will do now, for proportion, and for reliability generalization. These are the options. So we will see now this mean difference, because the outcome which we have set, that is the mean difference in case of a randomized control trial. So there's a plus sign here. Those of you who are installing this for the first time, you can click on this plus sign, this one. When you click, it shows the various installed module, and from here you can go to search for go to library, and you can search meta-analysis. Meta, so it shows you like major meta-analysis for Jamovi. Since it is installed, that's why it is writing installed. And again, that is meta umbrella, also umbrella review, which I think yesterday one participant was asking. That is also there. But since we have not performed any meta umbrella or umbrella review, that's why I have not installed it. So in Jamovi and JASP, the same feature is there in JASP also. If you click on the sign and enable that particular module, you can get it. So since I have got this major module, so all of you please install that and download the Jamovi, because in the breakout room, you have to share your screen and show it. So now I'll import the sheet. So click on this 3 horizontal line and click on this open. Now let me close this sheet. Why? Because then otherwise there will be difficulty in importing. So I'll close this sheet. I'll go to this 3 horizontal line. We'll click on open, browse, and show the path. So right now I am into this session 5. So here, this is my Excel sheet. We have provided you the Jamovi sheet also for analysis, but you should know how to import. That's why I'm telling you. So this is my mean and SD for this meta-analysis. So I'll open this sheet. And you can see like we have got this, where I have all the studies. There are 12 studies. There's a number in the intervention group, mean in the intervention group, standard deviation. Similarly, number in the intervention in the control group, mean of the control group, and standard deviation of the control group. So now I'll go and start with this major. So if you click this major, and I have to do the meta-analysis of the mean and standard this thing. So I'll click on this interface, and then you can see these are the variables. So first you move the study here to the study label. This here. Study, if you see the study label, move your this variable study to study label. And then we have arranged the data like this. So group 1 sample size, you enter the number. Again, if you see this number is in this categorical. So go to this variable, click on this, and change from nominal to continuous, because this data is continuous. Similarly, from this icon, you can come to this number also and change from nominal to continuous. Why? Because if you click this, here it is only the scale variable which should be entered. You can see this icon of scale. Scale means all these variables are scale. There's a small scale icon is there. That means these variables are scale variable. So enter here, then mean and intervention and standard deviation of intervention. 1 we generally take as intervention, 2 we generally take as control. So 2 again you can enter group 2 sample size, this mean of control and standard deviation of the control. And wait for some time. Oh, it is buffering. So you see that in mean it gives you the write-up also. You can see here. The Jamovi does this write-up, and we'll see. You can again, these are the assumptions which the Jamovi assumes before analyzing the result. So now coming to this, automatically it takes the random effect model, and this K is the total number of studies. And if you see this thing, intercept, this is 0.71, and we will see all this. And now coming to the heterogeneity statistics. So if you see the I-square is 88%, which is very high I-square. Again, if you see H-square, this is also larger than 1. And if you see this Q statistics, the value of Q statistics, it is significant. So that all shows that there are high heterogeneity. And you can read this also. We'll see. Let me first show you the other options. If you see the model options, there are two options like restricted maximum likelihood, and then there is this one, D. Simeon-Laird. So I'm not telling you these various model options. This is best, this Der Simeon-Laird model. This is the standard one. You can use this. And then your effect size is not on the standardized mean difference, but it is the raw mean difference, because raw mean difference is easy to interpret. Standardized is like, how will you interpret? So that's why if you change this to raw mean difference, here you can see this gives you the pooled effect size, like -22 means there was a reduction of 22 hours. And then I'm not putting any moderator here right now. And coming to plots, if you click on this plot, then you can see, you can put this weight. So I think one participant was asking regarding weight, probably Kainat has asked regarding how to put weight. So if you click on this model fitting weight and forest plot size, again you can choose from here whether you want a small or a medium. Let's say I want a medium one. And again, I talked about that prediction interval. So you can click on this prediction interval. And this x-axis title, will be the reduction in mean duration of diarrhea. So I will write mean duration of diarrhea. So now I'll explain this. This was the forest plot which we have seen regarding that high dose and low dose statin therapy, moderate dose statin therapy. So the first, this is the column of your study which you have entered, and this is your individual study, these one. So you can see here the narrower one is having a more, the way we have discussed, larger confidence interval having small number of boxes, and narrower confidence interval having big square. And this is the weight. If you see weight of the study, it is Basu is 8.94. This Chen is 9.39. Again, this is 8.39. And this is the it's the duration of diarrhea, the difference in mean difference, and the standard, this confidence interval. Coming to this, but generally we see the overall effect size, overall pooled estimate.
Axis दिखा
So this is the axis.
दिखा
Remember, I have written here in the x-axis mean duration of diarrhea. So this mean duration of diarrhea, it is getting reflected here. And this is like the 0, 1. And then this is from 0 towards this side. So in the diagram, you have to write like this, like favored or the less. I mean, if it is a reduction, then this is our desired result. And this RE model means random effect model. This diamond is
हेलो
the
मैम
highest.
मैम ये मीन डिफरेंस का फर्स्ट पॉइंट है ना एक्स एक्सिस स्टेप्स यू हैव रिटन 5 व्हाट इज दिस मैम
That is the like division. Like let's
Okay.
change this to 10.
ओके फाइन इट्स डिवीजन
Let
तो
me
ये
check.
स्केल बेसिकली
Yeah.
हाँ
So now you can see 0 and 20. And then it is minus 30. Like each scale, can you see? Like one division is 10. Distance
यस
is
मैम
10,
यस मैम
20, 30, 40, 50, 60.
यस मैम फाइन
And this is the confidence interval. So this is the diamond, this one. And if you see, the confidence interval is from minus 31 to minus 13. That means that the studies, if like we are 95% confident that the studies which are like population true mean, true value will lies in between these two, right? This is we mean by confidence interval, and this is the pooled estimate. And this 2 point that shows that the two end of this point shows the confidence interval of the pooled estimate. And then there is another, this dash 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 line, these two. Can you see these two? These two are the prediction interval. Remember, we talked about the prediction interval. So there is a confidence interval. So these two are the confidence interval, this and this. And then this and this is the prediction interval. So prediction interval, if you see, if I go through the write-up. So can someone read this? Is it visible? First read this section.
Okay, I'll do, ma'am.
Thank you. This part.
Okay. The analysis was carried out using the mean difference as the outcome measure. A random effect model was fitted to the data. The amount of heterogeneity, that is tau square, was estimated using the Der-Simonian lagged estimator. In addition to the estimate of tau square, the Q-test for heterogeneity, that is Cochrane, and the I-square statistics are reported. In case any amount of heterogeneity is detected, that is tau square is greater than 0, regardless of the results of the Q-test, a prediction interval for the two outcomes is also provided. Studentized residuals and Cook's distances are used to examine whether studies may be outliers and are influential in the context of the model. Studies with a studentized residual larger than 100, the percentile of a standard normal distribution, are considered potential outliers, that is using a Born-Ferroni correction with two-sided alpha equal to 0.05 into kappa studies included in the meta-analysis. Studies with a Cook's distance larger than the median plus 6 times the interquartile range of the Cook's distance are considered to be influential. The rank correlation test and the regression test using the standard error of the observed outcomes as predictor are used to check for funnel plot asymmetry.
So if you see this write-up, this is basically the statistical analysis. It is not the result actually, it is the statistical analysis which the Jamovi is using in the background. We have not told you the Cook's distance and there was one more point now, influential point and Cook's distance, that we'll see. We are going one by one, but this is the statistical analysis, how the Jamovi has done it. Now, you can continue with the second paragraph. This one.
Okay. The total of K is equal to 13 studies were included in the analysis. The observed mean differences ranged from minus 69.6 to 4.8, with the majority of estimates being negative, 92%. The estimated average mean difference based on the random effects model was minus 22.8459. It is 95% confidence interval, that is minus 31.8 to minus 13.86. Therefore, the average outcome differed significantly from 0. Z is equal to minus 4.9, P less than 0.0001. According to the Q test, the two outcomes appear to be heterogeneous. A 95% prediction interval for the true outcomes is given by minus 53.1 to 7.4. Hence, although the average outcome is estimated to be negative, in some studies, the true outcome may in fact be positive. An examination of the student-sized residuals revealed that one study, Erdogan, had a value larger than plus or minus 2.8 and may be potential outlier in the context of this model. According to the Cook's distances, two studies, Basu and Erdogan, could be considered to be overly influential. Neither the rank correlation nor the regression test indicated any funnel plot asymmetry.
So thank you, Vishnu, Priya. And in this case, Jamovi only tells you like which is the influential point or outlier, and then you can perform the analysis, filtering those studies out, and then you can try seeing about the value of I square. So if you see, these are like studentized, I will tell you that also. But have you understood the prediction interval, which you have just read here, that the prediction interval, it is minus 53 to 7.4, means plus, that means there may be a case in future that if you give probiotic, the average duration might increase by 7 hours also of diarrhea. That we mean by the prediction interval. And then it is different from the confidence interval. So if you see this was regarding this, and here whatever is the p value, this p value is giving you the significance of this estimate, because if you see this diamond, this is lying away from diamond and the confidence interval. This is very much within this, like before this 0. Not it is there. I mean, it is not crossing that line. So that's why this p value is significant. And coming to this publication bias assessment, if you see, we discussed these 4 tests. Remember, Pale, Self test, and Begg and Majumdar. So if you see the p value, it is non-significant. So you can say that there is no publication bias. If you see the funnel plot, in funnel plot, you can see x and y axis. So x-axis tells you the mean difference and y-axis gives you the standard error. So you can say like, yes, there is some like 5 studies are here and more studies are towards this side. And this tells you like that minus 22, this is the effect size, the true pooled effect size, minus 22 hours. So there's few studies which are lying outside this, like 2 studies outside this triangle and 1 study outside this. You cannot know like which are these studies. So probably 3 studies it has also pointed out. Erdogan and Basu and I think 1 more. So maybe it may be those studies, but again, you have to report Erdogan and the Basu and Erdogan, these two studies. So this is the publication bias, and these are the 4 tests. And we have told you that Rosenthal method. Remember, we have discussed that Rosenthal method we use for testing this. And then these are again, if you see the other options. Now this much is okay, like for you at this stage. So you can report, you can copy paste this, right click. If you right click this, you can copy and you can paste it. This also, it will be, you can show this. We will have another session how to show your result. This whole will be like you can just copy and you can paste it. This forest plot and this write up, this part you can write it in the this thing, in the analysis part, how it has performed the analysis. And then in the additional option, if you want to see that Cook's distance and all, I'll just show you. I have not removed. So show influential point diagnostic. So here it will show you it gives you all those Cook's distance and standardized. So the study which is marked in red, that it is considered as like outlier. So here there's a one study which is outlier. And study number 8. So you can see from this data, which is the study number 8. So according, yes,
Francavilla.
yeah. And during this thing, they have mentioned regarding the other. That also we will see how to filter that out. But currently, I am not showing you that. Once, first you do this much of activity in the breakout room, and then we'll see.
Thank you. 9 number.
Okay, yes, huh? Yeah, you are right.
वहां से नहीं देखेंगे ना
We'll see this 8. This 8, okay? Because it takes the serial number. So it is Erdogan. वो वहां पे भी था. Erdogan 212. This one is there. Francavilla is 9. It takes this one. Serial number. So if it is okay, we can go to the breakout room. So Dr. Anand or Akash, are you there?
Yes, ma'am. Nice.
Malak, could you learn over Jamovi these basic? I have to tell you a few more things, but have you understood up till this point?
Yes, ma'am, but still need some more practice because Jamovi is I am using the first time. So
Okay. But interface is easy, and once you start doing it, I think you will be able to do. There are videos related to Jamovi on the YouTube. You can watch that. And but again, even if you don't watch that, this is easy. Which is showing finite value. Let me see the chat. Or so
कुछ फाइल के गड़बड़ी हुई।
showing need finite. Dr. Madhu,
कौन सा फाइल?
which file have you opened, Dr. Madhu? Have you shared your
Nice,
screen?
man.
And,
Somebody has shared a screen.
okay, so
Ma'am, with Dr. Madhu, there was an issue.
yeah.
Like while he was doing in this one only, mean standard deviation, in that only. But whenever he was after entering everything, also that wrong, that some prompt was coming like that.
स्क्रीनशॉट भेजने के लिए।
So can you, Dr. Madhu, can you send the screenshot in the WhatsApp group also? You can send it. Have you downloaded the
Sure, man. I'll send.
current version or solid version?
Yes, man. Current version only, man.
No, you have to download the solid version.
Oh, okay.
Current version.
Current version has got some issue. Why? Because modules are getting added and
Oh,
many
okay.
features are not stabilized. So what you do, You
madam.
delete that and download the current version, which is like 0.28.
Okay, madam. Sure, madam.
And then I think it will be corrected.
Okay, madam.
And even if some issues persist, then again you can like post in the WhatsApp group. Otherwise, for rest of the people, can we see like any issues with any other person? Or like Dr. Pramod, Dr. Kamran, Dr. Amit. I think it's good. So then once if you have learned this, then I'll show you few like other nitty-gritty of this Jamovi, means related to meta-analysis only. So remember, it is suggesting you to remove few studies because currently, okay, I'll tell you that funnel plot is, again, it is, let me first tell this, Dr. Vishnu, and then I'll tell you that funnel plot also. This is regarding this we have done till now, and in this you see that it is asking you that Basu and Erdogan, these are the two studies, and we have seen in this influential point analysis also, if you see the Cook's distance in additional output, the plot of influential diagnostic. So generally we see the first two one. I'm just showing it. I don't need to like copy paste this result in the analysis, but only just for the like standardized residual. If you see this, then this Erdogan and Basu, here it is only 8-number study, but Jamovi is suggesting Basu also because this first is, I guess, first study is Basu. Let me see. Yes, Basu is first. So it is going above 2, this black one, this one. So probably that's why, although it is not red, but it is also showing. So what we can do, we can apply filter for all these studies. So how to, because right now, if the value of I square is 86%, if you see the value of I square, this is so heterogeneous, 88%. This in this much heterogeneity, it is not ideal to perform meta-analysis because if the studies are so heterogeneous, there will be no meaning of this pooled effect. So at least we have learned, like if it is more than 75%, you should not perform the meta-analysis, and you should write that since there was a huge heterogeneity, that's why we are not giving the result of meta-analysis. But again, you can try doing some like removing some studies, some adjustment in the study so that you can reduce this I square. So again, Jamobi is suggesting you to remove Basu and Erdogan. Erdogan, this one, that $1 one. So there is an option in Jamovi which is filter. So click on this filter and then we have to select a row. So how to select a row? You put this bracket and then put this exclamation mark. This is a command for deselecting a row. And then I don't want this row. So which row? First, I will select this Erdogan, which is 8-number. So I'll put 8 here. And I'll just close this. No, the formula is misspecified. Control J. Let me do it again. So is equal to, let me do it again. So row, bracket, exclamation mark, and is equal to 8. So now you can see this 8-number. It has deselected. There is a cross here. So it has deselected. So you have to type row, then bracket, and then exclamation mark is equal to this much row. That means now this analysis is not taking the this particular study of Erdogan. So let's see what is the value of I square. So we have duplicated the result because the interface of Jamovi is dynamic. So you don't, this will not remember the initial I square. Okay, so I have not duplicated, I'll duplicate it. So what I'll do, you can make this, I have created this filter, but you can make this filter inactive. So click this button. So now this filter will be inactive, and now this study, this Erdogan will also be included. So currently the I-square is 88%. So I need to duplicate this result. How you can do that? Go to analysis and duplicate. There is an option of duplicate. Duplicate this. So now you can see that this analysis, the upper one analysis will be there. And now another, this active analysis tab is open. So this gray one will be the previous one, and then white has started appearing. That means you are into this sheet. Now I will make that filter on. So I'll go and I'll click on this filter and I'll make this active. And now see the value of I-square. So if you see the value of I-square, from 88%, it has reduced to 86%, only 2%. Again, it is asking you to remove one study, which is BASU. Remove means in from the analysis. So I'll again go to the filter, again apply. So if you need to add filter, you click this plus sign. Click this plus sign and then copy this and paste this. And instead of 8, see which is the row for BASU. So BASU is 1. So I have put this 1. And I'll just close this tab. So you can see this BASU is also, there's a cut in front of BASU. That means this also got deleted from the analysis or filtered from the analysis. The better word is filtered. Now you see the R-square. Now the R-square is 78%. It has decreased further. And if you read this, it is again asking that there is another study. See, according to Cook's distance, if you read this, according to Cook's distance, one study Datta could be considered overly influential. So now I'll again put a filter over Datta. So I'll again put a new filter. And then I'll see where is Datta.
filter 2 है वो.
Okay, sorry. So just a sec. I'll copy this and I'll paste and I'll see Datta. So Datta is in row 6. So I'll click 6. And then I'll see. So now if you see, so now see the I-square. How much is the I-square? So from 88%, it has gone down to 27%. So less. And even if you see the other values of like prediction interval, initially the prediction interval was increasing. It was saying that in future it might increase also. But now if you see, it is very much away from this. And let me click the prediction interval. Okay. And prediction interval is again. Can you see?
आपको क्वालिटी अप्रेजल को भी देखना होगा तब तक.
This much.
कंबाइन करता है then. So
So now it is no more of positive one. It is towards the same side of 0, both the prediction interval and this confidence interval. So have you understood how you can and again there is a yes. Let me first explain how you can make, if you wish to put that filter off, anytime you can on and off this filter. You can make this inactive and active. That's the advantage here in Jamovi, that you apply the filter. If you make it inactive, it is not working. If you make it active, it is working. And again, with this, you will also go and see the quality of study or risk of bias of all these 3 studies. Because you have to take a holistic decision, whether just for the decreasing I-square, you will not do this. Rather, you will take a holistic decision. But again, you should try it and you can report it again after seeing the strength of the study, whether the study is of low, moderate, or of very good quality. So this is how you can perform with a with a mean. This is only with a mean and the standard deviation. One type of meta-analysis. There are other types also, but we have only discussed in this session as this mean and standard deviation. So have you understood how we have use the filter option and use this to see what was the effect? And now if you see, it is writing. Now it is saying that the heterogeneity is in 7 then. Studies are generally in the same direction as the estimated average outcome. And student eyes, they reveal that there was no indication of outlier in context of this model. And according to Cook's distance, none of the studies could be considered to be overly influential. And neither the rank correlation nor the regression test indicated any funnel plot asymmetry. Now coming to Vishnu's question of funnel plot. So in this case, you will see that funnel plot. I'll show you the previous one. If you see the
previous भी चैनल रहता है इसमें
okay,
बोलते हैं आपको फिल्टर हटा के इवेंट
so let me change the
कॉपी करने में वो इफेक्ट बैकग्राउंड में चला जाता
off. I'll make this filter off and I'll show you the funnel plot. So now no filter is working. So if you see this funnel plot, there are two studies which are lying outside this. This is the triangle. So there may be, if you see the plot, there may be, evidence of publication bias is there. And the rest of the study, if you see this vertical line, this is your 22R. That means the pooled effect. And if you see the two spread, there are some studies which are like towards right side of this pooled effect, 4 studies, and there are like 6 studies which are towards the left side. So kind of symmetry is there, but there are 2 studies which are lying outside. But if you make this filter on, I am enabling all these 3 filter.
है
So now you can see like all these are under this triangle. नहीं देखो ये तो है पहले. I don't know. So this is the funnel plot excluding those 3 studies. So now it is under this triangle. So this is the interpretation of funnel plot. Have you understood, Dr. Vishnu?
Ma'am, outside the funnel means what? I
Means
didn't
there
get.
is a publication bias because funnel plot tells you the publication bias. It's a visual interpretation of publication bias.
Okay. And this median line signifies.
This tells you this median line effect size. It's the effect size, which is minus 22 hours. This one. If you see this is minus 22 or whatever is the, let me see, which is the next one. So this value is of minus 25 because in the newer one it is 25. So this is minus 25, this value. Yeah, towards the right and towards the left side. So I think the rest, because we are left with demonstrating the proportion. If we have only done, if you see this option, we have shown you only the mean difference. Now, two more, one is of proportion, and then next is of your effect size
Dichotomous V2
and dichotomous. So
And-
3 demo
and Delman.
and Revman also. 4 things and Prisma. So for all these sessions, we need another 3-hour session, half day. Probably it will be completed in 3 hours. So now you have to tell us when to have.
Next week.
But it should be next week. In this week, we are relatively packed. So any day next week, or if you suggest, maybe we can have a poll. Any Sunday. Sunday, relatively next week is fine with me. I think we will send them the pool 2-3 days with option. Saturday is fine with us also. Sunday is little difficult. April 5th.
Next Wednesday.
Whenever we'll keep it in the second half.
Yes,
From
madam.
A Saturday for first half.
And if it is on Saturday, then from 10 to 1. Because Saturday our institute is closed. So from 10 to 1. So any weekday from either from 2 to 5 or Saturday from 10 to 1. You can pick. Sunday it's difficult because of some personal reasons. That's
The
why.
next week we'll do, madam. Weekdays.
Okay. Next
Second
week.
half.
Okay, fine. Fine. We'll have a poll in the WhatsApp group probably because right now, okay, 5th April people are saying, okay, we are, see what is the day?
Saturday.
Saturday, 5th April.
Hmm.
So 5th, are you guys okay from 10 to 1?
Yes, madam.
Hello.
Yes,
Okay.
madam.
Okay, fine.
Good evening.
The pool is open.
Then let's decide. It will be 5th. Those of you who could not join, you can, like the way you do, see the video and you can do it. But again, because
I'm not
we will have the breakout room.
Speaking.
So see how if you can join. Otherwise, it's okay.
I'm right now in a workshop.
So I think probably so we are ending today's session. Okay. Okay. So see you people on 5th. Okay. So thank you everyone. You will get the today's recording the way you are getting. So see you on 5th.
Ma'am, can we get the PPTs, madam?
Drive, man. Everything is in Drive.
Okay. Dr. Shamshad is saying everything is in Drive. You can open the Drive and see.
Everything is available in?
There's a Google Drive link which we
Okay,
have
ma'am.
given.
Okay, ma'am.
If you
Thank
open that, just check. All of you, please go and check it. Because then you will be assured that you have everything. Otherwise, there's a kind of like something is missing. So you go and check your Google Drive. Please open each and every folder and see. Then you will be relaxed. Okay, so we are ending the meeting from our end. Thank you so much.